Famous structural disasters that changed engineering forever. Welcome back to Blueprint to Reality, the channel where the world's greatest engineering lessons are written in steel, concrete, and sometimes failure. Every design code, safety rule, and calculation method we use today exists for a reason. Often, that reason is a disaster that forced engineering to evolve. Today we explore famous structural disasters that changed engineering forever. Introduction. Engineering progress is rarely smooth. It advances through trial, success, and sometimes catastrophic failure. When a major structure collapses, it does more than cause damage. It exposes hidden assumptions, it rewrites design philosophies, it reshapes engineering education. In this video, we'll examine landmark structural disasters and the permanent changes they triggered in the engineering world. 1. Tacoma Narrows Bridge. The birth of aerodynamic design. Before 1940, wind was treated as a simple lateral force. The disaster. The bridge entered violent torsional oscillations. Aeroelastic flutter caused total collapse. Wind speeds were not extreme. Engineering impact. Wind tunnel testing became mandatory. Aerodynamics became a core design discipline. Bridge decks were redesigned for airflow. Modern long-span bridges exist because of this failure. 2. Ronan Point. The age of progressive collapse design. A small gas explosion led to a massive partial collapse. The disaster. Weak panel connections, no redundancy. Local failure caused global collapse. Engineering impact. Introduction of robustness requirements. Progressive collapse checks in design code. Stronger connection detailing. This disaster changed how engineers think about structural continuity. 3. Hyatt Regency Walkway. Connections matter. One of the deadliest structural failures in history occurred during normal use. The disaster. Design change, doubled connection loads, inadequate review process. Walkways collapsed suddenly. Engineering impact. Mandatory design change reviews, increased focus on connection design. Ethical responsibility emphasized in engineering education. This failure redefined professional accountability. 4. Quebec Bridge. Engineering judgment over authority. This bridge collapsed during construction, killing dozens. The disaster. Underestimated dead load warning signs, ignored engineers, overruled by management pressure. Engineering impact. Importance of independent design checks. Engineers empowered to halt construction. Ethics placed above deadlines. Engineering judgment gained legal and moral authority. 5. Sleipner, a platform. The limits of computer models. A cutting-edge offshore structure failed during testing. The disaster. Finite element model underestimated stresses. Thin concrete walls failed explosively. Engineering impact. Verification of numerical models. Conservative modeling practices increased safety factors. Computers assist engineers, they don't replace them. 6. Champlain Towers South. Durability is structural design. A residential tower collapsed decades after construction. The disaster. Long-term corrosion waterproofing failure delayed maintenance. Engineering impact. Increased focus on durability. Mandatory inspections for aging buildings. Life cycle design philosophy. Structures must survive time, not just loads. 7. Fayoux Pedestrian Bridge. Warning signs must be acted upon. A modern bridge collapsed before opening. The disaster. Severe cracking, ignored misinterpretation of structural behavior. Failure under self-weight. Engineering impact. Crack evaluation protocols. Construction stage analysis. Stronger peer review requirements. Cracks are messages, not cosmetic flaws. Why disasters change engineering? Each disaster exposes blind spots, forces code revisions, changes design philosophy, improves public safety. Engineering evolves not because it wants to, but because it must. Lessons for engineers and students. These failures teach us. Safety margins exist for a reason. Ethics matter as much as equations. Assumptions are dangerous. Nature always has the final say. Studying failure is not pessimism. It's responsibility. Conclusion. The structures we design today stand on the lessons of yesterday's failures. Every disaster listed here saved countless future lives, made structures safer, made engineers wiser. Engineering is not defined by perfection, but by how deeply it learns from failure. If this video changed how you see engineering disasters, like, share, and subscribe to Blueprint to Reality. Comment below. Which disaster should we analyze in full detail next? At Blueprint to Reality, we honor failure because it made engineering stronger. See you in the next video.